what I thought about for the schedule. Okay, so we are live on YouTube. So welcome to day 3 of our workshop. So the idea that I had in mind for wait a second. There's somebody in the waiting room. The idea that I had was to have for today, tomorrow, and Friday to stream and gather together in a few review sessions. So today we're gonna have a review session at 2 p.m. and stream that. Tomorrow we're gonna have 2 review sessions, one at 9 a.m. and then the other one, which will be the last review session, at 2 p.m. Does it work for you? Then on Friday, we will gather together only for the final presentation. During the entire time, I will be available. You can shoot me a message on whatever you prefer between, I think the Zoom chat can be effective because I think you can look for my contact in Zoom or add me on Zoom and start chatting there, or also through email. And if there's anything that might be of global interest for everyone, we can have an instant Zoom. I can call an instant Zoom meeting to discuss it, but we don't need to stream that. Okay, we will only stream the reviews at this appointed time, so the people who want to follow on YouTube know exactly when the stream are going to be. And we put these calendars. Does it work for you?
Yeah.
Yes.
Okay, cool. Okay, very cool. Meanwhile, I've put together a few remaining things to show you that you may want or may not want to incorporate in your workflow. There are a couple of things really. One is another thing, one more thing about the component design strategy. And the other one is one more strategy for post-processing that involves selective geometry and what you can do about it. But it's really, among all, regarding geometry, I think it's one flexible and powerful tool. So I just wanted to show it to you this morning. But before I go on, do you have any questions at all regarding anything workshop related?
Oh, good.
Okay, so let me share my screen right now so I can show you. Then I realized that unfortunately, the material that I put on Google Drive, for some reason I forgot to save the Rhino file in its correct configuration. So I will update the material if I found any other kinks. But starting with the slab, you don't need actually to open it on your computer. Just maybe follow what I'm showing on screen, because then it might be easier to understand the concept behind this, and then you can apply it to your own thing. So yesterday I was fiddling around and while working with some simple combination of components, the one that we were starting to see yesterday made of this block of 2 slabs, something occurred to my mind. I say, okay, these are like 2 identical slabs. So why not reduce it to 1 component and just change the location of the handles? So that, for example, this one or this combination that was a single component is actually one of the possible occurrences of how this thing are assembled together. So while doing this, then I tried it in a simple random assemblage. It could be that I get an error right now. Yeah, hold on. I think it's complaining a little bit. Yeah, it's complaining because of the thing that I told you, but no problem, because I'm going to just copy paste this thing and it should be okay. Is it? Oops. No, it's not okay. So let's try. Well, then I'm loading. Oh no, I'm loading the wrong heuristics. Sorry. Let's load this one. Okay, it should be fine. Well, not 1,000 at a time, but yeah, 10. So if you go on, it's totally random, so don't expect a lot of order to emerge, but you can already see that there are a very flexible range of possibilities for the assemblies just by actually reducing a lot the complexity of it, but enhancing cleverly actually the number of and position of the handles. So there is one that is exactly centered, one that is like 1/4, so it's half of the half here, and one that allows the two objects to form exactly a corner. And then with the rotation, you also have the possibilities of some overlappings, and some other emergent things can happen. But it will be interesting also to try to get out of this regular grid of overlapping just by moving these handles around a little bit, creating some sort of tatami organization in the interlocking of parts. The system will take care of all the inconsistencies, of all the potential overlapping or compenetration. But yeah, it was just to show that sometimes when you realize that your part is actually made of a combination of a simpler part, it could be even more interesting to reduce it to the elementary building block. More generic, less specified, and then you open up another range of combination. So one other thing that happened when I was teaching some of the students and also in the master, it was that sometimes they were, or a lot of people were attracted, for example, by hexagons. I like hexagons, nothing wrong about hexagons, don't get me wrong. But the hexagon is quite a specific figure already. And also, it has the properties that it's extremely symmetric in many directions. So if you tile up a lot of hexagons, it's really hard to come up with something that is that has some sense of direction, some anisotropy to it. It's a very isotropic figure, like all regular polygons, right? The pentagon has different properties, but still. Another thing that would be interesting is to get out of the square thing here and make the slab with different proportions so that you have an anisotropy also here and see what happens in the assemblage. That will become another interesting thing to see. But if you look at this, you can realize that you can break out this module, this regular thing, in multiple ways that give birth to something more interesting. For instance, you can break it in two, these two trapezoids. And if you think what a single trapezoid can do, yes, of course, they can combine and form the hexagon again, but then you have a lot more flexibility in what they can do as a figure later. Or you can break it in 3 parts. And then you have like 3 diamonds. Still, if you take one of these as a single figure, you have a lot more possibilities for an extended form of organization that goes more into something that is less static and less periodic than just repeating the hexagon itself. Then, of course, you can have the 6 triangles, but that starts to become a bit too much elementary and generic. So the figure becomes actually so unspecific that it becomes like geometric dust. You can make anything out of it, but it would give you no defining characteristic from the get-go. So the other thing that I wanted to show you was actually post-processing strategy. So I'm gonna save this. I will update the file related to the slab and then I will. You could download again the material from the same location. I will let you know when I did the update. So I'm gonna open the other part, which is the blocks. So in this case, I was working with some of the figures that were in one of the files that I already sent you about the components, but with one important update, which is so far it's not that important the shape of the object. It was just to get something modular that can attach in multiple ways. The thing is, I left these openings on purpose that are just in the final geometry. The collision mesh is still a closed mesh. They are on a separate folder because the collision mesh needs to be a closed mesh, like I told you, because otherwise the collision detection doesn't work. But this then is the final geometry. And in the openings, I've placed these two open polylines. So there is an open polyline or a closed polyline here. And here in the opening, there are like two handles, because the opening, if I switch the mesh on again, is basically made of two modules. So each of the modular part of the object can get into an opening. But then knowing which handle becomes connected or occupied, you know that some of the polylines might be available and some of the polylines might not be available anymore. So why then two open polylines instead of a single polyline? Because then you can select them by handle, and at the end of the assemblage, you can try joining all the open polylines. So the open polylines that would get joined will give you the single figure for this big aperture, this big opening, or this corner opening. Same principle. And if half of it is occupied, so this polyline gets filtered by the selection later, you only have, you're left with the open polyline. So you try to join everything to see if you get a larger figure. And then whatever polyline is left, you take it and you close it if it's not closed already. So this means that you can manage openings of different shape and size. And if you work it cleverly enough, you can also figure out when these openings starts to get stacked together. So you get like an enfilade of openings or like a vertical shaft of windows or something like that. So let me show you how it's worked out in the in an assemblage. So in this case, you can. There is also a definition that generates the heuristics, another one that generates a simple random assemblage. But since I want to focus just on the post-processing parts, I've saved also this definition that can load the. Is it loading the right one? Blocks 000, yeah, right. It's going to take a while because then the post-processing takes a little bit of time. Okay. It's not done. Taking its own time. But yeah, I think it's all right. So let me go to the end so I can focus the view on these parts. It's okay. Oh, I'm looking it upside down. All right. So starting from the assemblage that you load from here, that's some of the usual analytical breakup of the assembly object that you've already seen. So extracting the handle plane, extracting the reference plane for each of the components, extracting the object ID to recognize who is who, and also extracting the meshes for the preview. And then in here, I've placed a couple of groups that contain for the object at ID 0 and the object at ID 1 the extra geometry polylines that I was showing you, the reference plane, and the final geometry, which is the geometry with the opening, that then will be substituted to the collision geometry. So I need to filter, first of all, I need to, actually, I am combining all this data according to the object ID, so that here I have, for each of the objects in the assemblage, a list of their IDs. So I'm just associating to each of the objects the proper set of data. Curves, these are the indexes of the corresponding handles to each of those open polylines. So like the first open polyline is overlapped in the place of the handle 5. So if the handle 5 is occupied, I could filter the corresponding polyline out of the process. If the handle is open, is free, then the polyline is filtered in, and then I can use it to place my post-processing data in here. Same thing with the reference plane. To each object in the assemblage, I will associate the corresponding starting reference plane, because in the end, all you do is an orient operation. Then you orient everything in place. So everything that pertains the object with the ID 0 will reference the data from the object with the ID 0, his reference plane, so that he could do the proper orientation, the geometry, the new geometry, everything, so on and so forth. And also here, I am getting the pattern, just a Boolean pattern, that filters the free handles from the occupied or occluded handles. Remember, this is the process that we have seen yesterday. So just from the data about the neighbor handle, so you get the data about the handle occupancy. If it -1 is free, -2 is occluded, otherwise anything from 0 up is the index of the neighbor handle. So I can filter the free handles, but all I need is the pattern, which is for each object, what I am getting in here is a pattern of true and false that is ordered by handle index. So all I'm doing is I'm picking from this list that is general for all the objects, just the right indexes for each object ID. So for every object that has ID 0, I'm going to pick the value true or false at index 5, 4, and 2. So I know that, for instance, the first object is ID 0, and handle 5 is occupied, handle 4 and 2 are free. So I know that 2 of the 3 polylines that are in that object are available to do something. Same thing for the other. This has 4 values, so it's type ID 1. Handle 0315, they are all free. Perfect. I can use all of them. So once I have done this filtering, I'm applying this filter to the polylines. The polylines are traveling as a group for simplicity, so that I can distribute them according to the object ID. And then once they are oriented, they get unpacked as polylines. So if you switch on the ungroup after the orient, you will see that all the polylines have been oriented in place properly in the position of their corresponding object. And then I need to filter them, but I already have my filtering pattern here. So if you look at the important thing that you have to check out is both the number of data and the structure. Number of data and structure should be absolutely identical, so that for each polyline or each corresponding data that you want to filter, you have a corresponding value in the pattern of true-false. So this tells me I have 827 data in 207 branches, and this is exactly the same. So I can use it and just filter out the positive data, and then I have only the polylines that are positive. Unfortunately, I don't know for whichever reason, I need to check. This has to do with the occlusion mechanism. That is still not perfect. So some of the polylines fail to check as occluded. Also, this has to do with the geometry of the object, meaning that even if these objects look connected, it might be they just fell into place like this because of modularity, but the connection is maybe elsewhere. So it might be also that. But it doesn't kill the principle. I mean, you might have to go and check out if something like that happens. It could be also that it's because the geometry that I used didn't have any thickness. It's closed geometry, but I don't know. I still have to find out why some of the occlusion check did fail. And in there, what I'm trying to do is I'm not going in this case to try and get the more complex geometry. I'm saying, okay, just close everything, even if they are single modules, I don't care. And then I'm just making a surface, sampling the surface and generating this kind of mesh louvers all over. Of course, once you have those polylines, you can do a lot more things. I mean, this is just a simple thing. You can design a set of geometric objects that work within those polylines, and then selectively orient those. Maybe sample the condition of the surface once it is in place in the assemblage, and then differentiate whatever appears on that polyline according to position, to other condition, to other checks that you do around. So the polylines are an extremely flexible reference for geometry. Because about the polyline, what you can read, it's first of all the fact that you read the plane and the position. Second, you can read the area of the polyline. You can read the proportions. You can read all other sorts of data associated with that geometry and act accordingly. So if you do maybe join the polylines and you want to find out the large one compared to the small ones, you can filter them by area. And then you're going to have the large one all in one channel and the small one all in another channel. If you want to check if you join the this kind of polyline or the corner kind, you just check for the planarity. And then you know that you're going to have the planar or the non-planar situation. And then you can act accordingly again. I mean, there is a lot of things that you can come up with this process. It's just a selective way of, let's say, having to deal with this. So right now, all of the geometries that I used to plug the holes are actually the same because I just wanted to make it really, really simple. But then you can change it according to the local condition. Like I was saying yesterday, the most elementary thing would be, okay, let's read an external data field and change maybe the density of those louvers according to the data field. That's the most elementary variation you can do. Or you can have these louvers maybe not be just long pieces, but small pieces that have a rotation. And then according to local field data, you have a distributed pattern that it's not anymore modular with the object, but depends on a condition that it's distributed in space in the whole assemblage. Anything that comes to your mind, I just suggest to keep it really simple and very close to maybe the abstract condition. Don't go too much into the detail because the geometry really propagates and multiplicates, and you have a lot of instances very quickly. So if you want to try, it's enough that you do something that proves the principle and maybe becomes a way for the system to produce a pattern when it's stimulated by some global data. That would be the interesting part. I'm not really interested in the fact that you can, let's say, draw all like a proper window with all the details, with all the technical details and joints and nuts and bolts. That's not the scope of the work that we are trying to do in this small amount of time that we have. It's more about, okay, let's see how the distribution of information can produce patterns in geometry, and this geometry, they will have a sort of constructive correspondence, but it's not about, designing for production tonight or tomorrow. Also because I'll tell you, the amount of geometry that you will produce is going to be really, really big. So keep the geometries. Another reason to tend to keep the geometry as simple as possible so that you can enhance the quantity and have complexity by means of organization. And once again, not just by means of the single object in itself. So, yeah, that's pretty much what I wanted to show you this morning. Do you have something that you would like to show already? Or if you have something, then you already want some feedback about it. Otherwise, I would, or want to talk about your prompt or ideas, what you want to work about.
Yeah, with Jan, we began to think about what we want to do, and we.
Would you like to share the screen so I can?
Yeah, why not?
Yeah, wait a second. So I need to stop sharing mine and give you permission to do so. I need to make you co-host. So.
Oh.
Yeah. What an honor, right? No, it's just the only way for you to be able to share screen. I'm going to have to make everybody co-host at some point. You can share your screen at will. I still haven't found the global option to do that.
So yeah, the goal was to work with. We had two two references. So the ones that Jan was has sent already a mail yesterday about this kind of structures here. And for me, it was my references were more about some pipes and using some standard PVC pipes that we could assemble the way we want. So basically, I started by modeling a set of pipes connections like this. Based on the same grid of the same length. So I have maybe 5 or 6 modules like this. And the goal was to have 2 different scales. So the micro scales assemblage like this, and then taking this kind of parts and make another assemblage out of them. And so the goal was to really use the space as a texture and go a bit deep into that definition of texture. And so
oh man, no.
This is what I did for beginning. So it's just the beginning now. What I did yesterday.
Sorry, something. Sorry, my computer.
Oh, sorry. I
don't know. No. It was not. Not up to you. I don't know whatever happened to my computer, but now I'm back. Okay, I'm okay. You can go on.
Okay, so basically, what I did with this was to have some. I worked with a bit with the vector fields in order to manage the direction of the pipe. So at the extremities, the pipe should orient to the interfaces with other blocks, for instance. And then in the middle, I set some random vectors, as you can see, in order to have some more diversity and more complex structure inside. And then, yeah, at the other extremities, it's still the same. So because of the way the pipes are designed, there is still some regular space between the pipes. So I hope that when we will work on some other blocks like this, this could have some great interfaces like this, even if not all the pipes are connecting. Maybe we have half the pipes or so that are in front of each other when we do the rotations and the other assemblage. And so, yeah, this could be, we thought it could be great to work with different densities and orientation of the pipes, and in order to get some global movements and micro movements inside those parts. So yeah, that's it for now. So
okay,
I worked mainly on the micro scale, and then we thought this morning that maybe Jan could begin to work on those kind of blocks and assemblage of those blocks, and then we can like talk to each other to make some go and return and see how we can have some movements of pipes going on, etc.
Okay. I will. I can comment a few things on this. It's a very nice start. I would consider a few things going forward. First of all, maybe the scale difference between the micro object and the intermediate object, it's there's a too much span in these two scales, right? The bounding object that you want to use as a, let's say, a meta part and build out of it as a scale that it's really far away from the constituting object. So the risk is that you will probably come up with a few instances of this, but they will be very recognizable in the final assemblage in the end. So maybe try to work at an intermediate scale that it's not so distant from the elementary building block to make the meta parts. And then try to test quickly how the meta parts assemble together also.
Yeah.
Because then you have more chance, because then the problem is that you're going to have a very recognizable and quite restricted in terms of assembly of effect that emerge from the assemblage final effect, right? So probably try that. The second thing would be, I would introduce also a joint that works with the diagonals. So I would introduce some 45 degrees joint.
I had them. It's just that yesterday when I tried, it was messing a little bit everything up. But I will introduce them again. But for now, I just wanted to reduce the complexity to work with vectors, etc., and understand what happens inside the process. And then I will, we thought. We spoke about it like 30 minutes ago.
Okay. Sure.
We want to get this more.
No, that's okay. That's okay. The last thing, maybe have also an object. But you already have it. I see. That is not a joint, but just a simple length of pipe. Yeah. But you already have it. I see. Okay.
Now the thing is, I want more linear pipes. I want to understand how can I give more priority. I don't know if it's with the weight parameter, if I can do that, but for example, there are some connections here that are not used at all.
Are you using the random or something?
I'm using the vector field for the cell rule.
Okay. The weights are still a work in progress, and I didn't manage to put them at work properly, but that was one of the ideas that I had in mind. The thing is that, the selection of the receiver, it's random, but then it is going to choose the closest to the vector field. Probably one of the things that you can try is to duplicate some of the rules in the heuristics. If you duplicate or increase the repetition of one rule in the heuristics, it should get more probability to be caught.
Okay. Or I thought maybe I could, instead of working with vector field, I could maybe work with scalar fields with several parameters and prioritize one parameter over another. So maybe if I want to prioritize one direction, actually, is it possible to use the logic of the vector field into the scalar field? So
what do you mean?
For instance, at the extremities, I could prioritize one vector, one direction, and in the middle, more diversity, or one type of pipe, or I don't know exactly.
I mean, if for the selection of the receiver you use the scalar field, it will work with the areas of the scalar field closer to the threshold that you input. So for now, that's the only way in which the system works.
Okay.
What you're suggesting, it's really an interesting option, but right now the system is not developed to do that, not yet.
Okay. Okay. So yeah, now I still have to tune this because there are a lot of empty space and too regular. It converged to a very regular structure, and I want to have more like I don't know, you know, some good pipes movements like Sans Pompidou, or I don't know what, very dense pipe movements and directionality that can assemble with each other. So.
Okay, I would try maybe to also differentiate a little bit between the size of the node and the size of the pipe trait. Maybe have multiple length for the pipe traits.
Yeah.
And maybe make the node really, really, really minimal, like a little more than a cube with connection on the sides.
Yeah, I see. So maybe just extend for the straight pipe, have it like the double, 3, 4, 5 times, and only the connection. Yeah, I see.
Yeah, because what I see right now is that, or maybe just have two lengths, one short and one long. Maybe start with just two. That could be enough already to improve some more heterogeneity into the system. Yeah, because right now the size of the trait and the size of the node are almost identical in terms of bounding box. So I think that's one of the reasons that generate this sort of regularity in the grid.
Okay. So yeah, that's it for now. And so yeah, we'll
okay.
Together at 2 different scale and.
Cool. Someone else would like to show something, or do you have something you want to show? You didn't have to have anything. It was not mandatory for this morning, of course.
Actually,
go on.
Go ahead. You are working together anyhow, so it's okay.
Okay, thank you. I would like to ask about one more technical thing. I tried to do some initial setup with the scaffolding idea, which I am now more transversing to this volumetric idea, which Alexander will detail. But for the technical question, maybe can I share the screen and show you?
Just let me give you the permission.
Yeah. Can you see the screen?
Yeah, I can see it.
So I designed these elements of the scaffolding, which I thought I will use. And I managed to make the heuristic stable. So yeah, it's very simple. It's what you mentioned, that the hexagon is very symmetrical. So I wasn't that happy with the thing. But my question is more about the generating the assemblage, because somehow, like you can see, you can see here that this is what the assemblage generates, and if I reset it, it just goes these 2 steps.
Because it's because of the heuristics. I don't know, for whatever reason, the heuristics make so that once the knot has been occupied there, it gets totally occupied afterwards.
Yeah. So it should be something with setting the
it should connection. It should be something with the heuristic, but just to be on the safe side, I might ask you to send me the Rhino and the Grasshopper file, so I want to take a look if the problem is maybe elsewhere, just to let's say leave out any possible technical problems with the definitions.
It might be also orientation of the handlers, because I tried to make it all in Grasshopper. So maybe.
No, the thing is, it's weird that I think you have enough rules, but it's weird that the system just stops and doesn't add any other. Well,
Yeah.
I need to take a look at this directly, because
Yeah.
otherwise I'm maybe wasting too much time trying to figure it out from here.
Great. Yeah, I will send you the file. Thanks.
Okay, cool. So, if there isn't anything, anybody want?
I could go next if he's done.
Yeah, sure. Let me just give you the permission. There you can go. Should be able to share now.
Mm-hmm. So Andrea and myself, we are thinking about, he actually happened to be working on a project in New York. So why not pick up something which is like a waste product of the shipping industry and then make some...
Guys, can I tell you one thing about shipping containers and how much I do hate the things made with shipping containers for a gazillion reasons, and how they are such incredible fad of architecture in general. I mean, if you want to work with the block geometry, that's totally fine, but please don't bring shipping containers in the mix.
No.
Please, this is like a personal plea. I will have to spend the next 2 hours explaining why this is such a bad idea to use shipping containers, but well, yeah, I don't want to get into that, but please don't use shipping containers. I mean, use blocks. Block geometry is totally fine, the same proportion of the containers if you want, but please don't mention the containers.
Okay, all right.
We can have a longer... I mean, it's. I don't want to be brutal about this, but please, it's well motivated and well rooted, and I can give you a much more calm and detailed explanation without being polemic about it. But there is just not enough time to do that.
All right. So would you like us to?
No, go on, please. Go on. Sorry.
No, we actually had multiple ideas. I mean, this is the one thing that I could develop in the early morning of today. Yeah, I mean, if you're interested, I can show you further, or else we can totally come up with something else. I mean,
I was just. I mean, I wanted
I can skip the word shipping container altogether.
Yeah, let's talk more about the geometry and intention. So,
all right.
But I want to hear what you want to go for.
Okay. So yeah, so we basically had like a very simple and basic shape that we wanted to come and then further orient another geometry on top of it that would be much more detailed or complex one, we can call it. So yeah, I mean, the idea was to the handles that we create and the offsets that we have from the host or from the handler or the sender was to the offsets that you create, they are not exactly the same size. So there is perhaps a rectangular face, and then the object that sits on it is particularly a bit small. And
I think you are sharing just the web page and not the desktop. You have to choose when you have the share option desktop and not another window. Sorry,
I'm relatively new to this. Okay. Do you see the Rhino?
Okay, I'm seeing Rhino and Grasshopper now. Yes.
Okay. Cool. So yeah. So these were some basic iterations that we did in the morning, and just some what random heuristics that we come up outside it. And it was completely just like a very raw idea, and we just ran the standard definitions that you shared with us yesterday, and the kind of geometry it develops. And the question was, before we move further ahead, we wanted to get your first-hand opinion about it.
Okay, I mean, the idea of working with a basic block geometry, it's totally fine. I think you should capitalize exactly on what I was showing this morning about using maybe a single component and try to be clever with the connections.
Mm-hmm.
And then maybe out of that, out of the combination, you start to design geometries to put into this some sort of placeholder block, a geometry that might have also opening that has some space inside.
Yeah.
So I think the interesting part after, let's say, shrinking and making it the most minimal setup possible in terms of geometry would be to explore different conditions, maybe with the vector and scalar fields in the assemblage, so that you move beyond just the random aggregation. And the other part, maybe from the assemblies that you start to do randomly, the interesting idea is to say, okay, let's see what rules are generating something interesting and what rules are actually just making noise. So the other suggestion is try to be very selective with the rules. And maybe you can also be selective in different moments. So you start, you divide maybe the assemblage into phases, and in one phase you use a very specific set of rules, then you save it, then you go on with another specific set of rules. So you can start dividing the work in parallel for who tries to see the combination between handle positioning and the heuristics that follow, or the heuristic selection, and see how you get on with those combinations. Because then, I mean, you basically, what you have in your hands, you can treat it perfectly like a brick at some point. So you can design the handles to do all the sort of works that you can do with bricklaying, interleaving some space, or have a perfectly overlapped thing. But I think that the interesting thing to move beyond the perfect regularity, it's actually just a really clever positioning of the handles, so that you work with the certain, let's say, shifts in the overlapping that can generate some alternating pattern or some unexpected, assemblies, because then the assemblies will be definitely consistent in terms of connection and, solidity of the whole thing. But then you can reverse this with a good understanding of how to make the space inside of this block and how the shift would enable not maybe to have just one brick perfectly stacked over the other, but just some horizontal or vertical shift in the overlapping, so that you create this extra space that then can, let's say, enhance the diversity of the pattern.
Yeah, about that it's definitely possible at the end of the day to perhaps orient different kinds of geometries based on verticality or horizontality of the component, right?
Yeah, you can use the vector field to do that, so that if your object is actually perfect for that, because you can set up the direction of the object with a vector that goes along its larger size, its larger dimension. So then you can check the vector field checks exactly the angle of the direction with the direction of the field in that point.
Okay.
So you can also design the field to have exactly horizontality or verticality.
Okay. Right.
And also in horizontal, you can also have the field having like 90 degrees angle, so that the brick tends to be stacked one way or another.
Mm-hmm. All right. I don't have anything more than this.
Okay, that's cool. I think you have, that's an incredibly flexible, to me, nothing is really boring at some point or too much, let's say, elementary, because then you can always find ways or new ways in working with simplicity and get out complexity out of it just by break a little symmetry somehow.
Mm-hmm.
There was this I don't remember exactly now the name of the author, but it was maybe Paul William Anderson that was studying the complexity of crystals in 1972. And it turned out that the perfect regularity of the crystal was so different from the crystal at the eye level scale, because in the end, the crystal have this kind of broken symmetry. They never complete the symmetry full circle. So there is this kind of missing thing that enables the construction of a more complex structure at larger scale. So if you break a little bit the symmetry of the handle positioning, so that the construction enables this kind of thing, then you can experiment with different heuristics or different handle positioning and see what kind of complexity you can extract from the simplest object that anyone can think in terms of construction. I think it's an interesting challenge.
We'll work on these pointers that you gave.
All right, very good.
Thank you. Thank you for
You're welcome.
I'll stop sharing now.
All right, yeah, thanks. So it's already 10, so I don't know if anybody else would like to show something. I'm still available. Otherwise, maybe you can just work a little bit and have a. When did I say we're gonna have this? Yeah, I would think that it's more important to leave you time to work at this point, and then have a review meeting this afternoon at 2 p.m. What do you see? Is that okay? Like we said before?
Right. Yeah.
Yes, it's okay.
All right. In any case, I will be here with the computer open, if it doesn't melt, Zoom open. So if you want to reach me, either email or try Zoom chat. In any case, I am available for a quick feedback, and if there is something more important to be said at a general level, I will let you know. Okay.
Yeah.
All right, so have a nice and productive working morning. And if nothing comes up, I will see you at 2 p.m. Okay?
Okay, see you.
Great. See you guys. And for the YouTubers, we will connect back at 2 p.m.
Leave a like, YouTubers.
What? Sorry? Okay, leave like YouTubers.
Asked for a like for your YouTube.
Okay, all right. Yes, please. Everybody leave as many likes as you want.